Hello guys, welcome to the robot explanation video. Today I'll be showing you how our PTO works and how our robot works in general. So basically, as you can see here, we have 4 motors stacked together with 4 gears to transmit the power over here. We have a chain that chains to the back where these pneumatic pieces over here pushes the slide, so it can slide to touch the drivetrain like this. We also have the coupler mechanism so that we can really turn while actually driving, because we don't want to just drive forwards because it might mess up. So as you can see here, we have this gear over here that just pushes out when activated. I'll show you how our piston works. As you can see here, we have 2 pistons stacked on top of each other. They're connected to a corner connector, which pushes 2 shaft collars. As you can see, the 2 shaft collars just move, and it doesn't move that much because I have limiters. As you can see here, it just boop and boom. That's pretty much all there is to the video. For the elevator clutch system, we have 2 separate clutches. It's technically one big clutch, but the gears are on separate axles. We did this because we want to actually turn, and if it's on the same axle, then all the movement of the 4 motors will be synced. So as you can see here, we have 1 piston that pushes the 2 12-teeth gear clutches. As you can see, it does that. Over here, our intake system, right? It has a 32-teeth gear connected to a bevel 32-teeth gear. This allows to slide more smoothly along the gears. And over here, we have a 3-to-1 intake. We didn't use a 4-to-1 intake because we realized that it might get a bit too fast, and we don't want to get that fast. For our drivetrain, we have a phase mechanism over here. We use simultaneous phase because it's the most effective ones. And for the sleds, we use a 1x12 sled over here. This reaches to the bottom of the wheel, which is tangent, so that it has a perfect angle that it could go. Back here, we have a 4x12. This adds more support to our robots so it doesn't collapse. Hold on. This is our drivetrain. You might wonder, why is our drivetrain like this? Our drivetrain is shaped like this because, first of all, we have to make sure that it's able to full park. So we have these chains that grips the bar so they can go through smoothly. Furthermore, sometimes our full park is stuck on the battery. So to prevent that, we added these pieces as a cushion. So whenever it gets on the bar, these pieces could still be grip, even though it might bend a little bit. So normally over here, you see it's able to push down and it's very wiggly. But on here it has a small cushion, so it couldn't bend down as much. We use a 3-to-2 drivetrain now. It's 2-to-1 wouldn't work with how heavy the robot is. On the back, we didn't bracket our wheels because it allows us to double full park. Furthermore, we have these wiggly guiders that kind of fail to see our files match. These wiggly guiders, it's wheels. It's inspired by concave office one. These guiders change shape to allow the cubes to flow smoothly into the goal. Over here, we also have a double-layer purple mechanism. Our double-layer purple mechanism is inspired by simultaneous mechanism. It allows us to have a double layer even though the flip-up isn't connected to the elevator. We did this because we just didn't have space to put on the elevator. You might be wondering, this whole robot looks a bit out of size. How do you get it past section? So we actually have a lot of D-expansions. For example, our elevator floor, it could go down. As you can see here, we have this angle piece up here. This angle piece allows us for the elevator to flip up. And when it flips up, look what happens. The angle becomes over 180 degrees, which when it pushes down, it's not going to go back in its old position. Our flip-up is a bit different from the traditional flip-up mechanism. Traditionally, the flip-up flips out from outwards to inwards, but our flip-up flips us from inwards to outwards. This allows us to like slingshot the cubes up more easily. As you can see here, when I start the intake, nothing goes up, so if I just take the cube in, it shoots out. Anyways, our wall. We have a suspended wall that's not 100% suspended. It's hinged in the middle, as you can see. The top wiggles, the bottom wiggles, but the middle doesn't. We did this because our wall might sometimes get stuck in the intake, which caused it to permanently jam, and we just didn't want it to happen. Anyways, for our green storage, we have a hole over here. We have these slopes over here to allow it to flow smoothly, and to also block purple cubes from falling in. We have these pieces to help as like a bridge, so that green cubes can cross in smoothly into the storage, and it can't get blocked because it's a bridge. For purple, we have this angled middle piece that allows it to flow smoother. As you can see here, it flows pretty fast. And there's a small gap between two purples, so we can actually just like let one out, not let the other one out. There's one more thing about our robot that's very different from other designs. As you can see here, we actually have a plastic sheet over here, right? The plastic sheet has two plastic sheet guiders over here. This funnels the cubes in smoothly, and since it's not like it's not angled pieces, it's not stiff, so it changes shape to allow the different sizes of cubes pass through. And over here, as you can see, we have a bunch of rubber bands here. Remember asking, what's this for? It's just for cable management. It's nothing that important. Alright, this is all I have for a robot explanation video. See you guys next season, and I hope you guys do well.